Alright, this video should help you with the final section of your review assignment, mole conversions and stoichiometry, going between moles and grams, moles and liters, moles and units, or going between grams of one substance to grams of another in terms of stoichiometry. So just as a quick reminder, 1 mole of any substance is the same as its molar mass in grams and is also equivalent to 6.02 times 10 to the 23rd units, being atoms, molecules, formula units, or you could even consider ions. And it's also equivalent to 22.4 liters for gases that are at STP. So we can use those as our conversions to switch between quantities of a substance or different substances. With percent composition, this is just a ratio, the amount of the particular element or substance that you're looking at over the mass of that compound times 100. And then with stoichiometry, you do have to account for the ratio that's used to relate the substances to one another from a balanced equation. So it's basically acting as your chemistry recipe. So the first example we're going to talk about, how many liters are in 24 grams of CO2 at STP. So I start with what I'm given, just like we did with dimensional analysis, 24 grams of carbon dioxide. Grams needs to go in the denominator because I want to cancel it out. Liters goes in the numerator, that's what I'm trying to find. In case you've forgotten, STP represents standard temperature and pressure, and for 1 mole of a gas under those conditions, it's the same as 22.4 liters. That number will not change, but the grams is dependent on the masses of the elements making up that substance. So for carbon dioxide, I would take 1 carbon and 2 oxygens and combine those together to get the molar mass of CO2, 44.01. The 22.4 would go with liters. In terms of significant figures, I want to look at my starting value, and I also want to look at my molar mass because those are based on measurements. The grams cancel. 24 has 2 sig figs, so when I multiply and divide, I want to have 2 sig figs in my answer, and I just got an answer when I calculated that to be 12 liters. The next example, what is the percentage of nitrogen and magnesium nitrate, MgNO32? So if I want to know nitrogen, I have to account for how much nitrogen is in that compound. There are 2 of them, so I would take 2 times nitrogen's mass, and that would go in my numerator. Then I would have in my denominator the mass of that whole substance. So if I look on my periodic table, I'm going to be able to find the mass of magnesium, the mass of 2 nitrogens, and a mass of 6 oxygens. And when I add those together, I get a total mass of 148.33 grams. So the percentage of nitrogen would be the 28.02 for the 2 nitrogens over the 148.33 grams of the whole substance times 100. And with percentages, as I've said previously, you will be allowed to round those to 1 decimal place. The grams cancel out, and you're left with 18.9%. Alright, and one last example with stoichiometry. We know that this is stoichiometry as opposed to a conversion because you are switching between substances. I asked you how many moles of silver sulfide are produced from 3.01 times 10 to the 23rd molecules of molecular sulfur, F8. So you are starting with that quantity of F8 molecules, 3.01 times 10 to the 23rd. When I set up my conversion factor, I need to account for the fact that I want to cancel out the molecules of S8, and I want to find moles of silver sulfide. So with molecules or atoms or ions or formula units, Avogadro's number is always going to be used to represent 1 mole of that substance, and moles is always going to default to 1. I now need to look at the balanced equation to relate S8, the sulfur molecules, to silver sulfide, and I see that 1 sulfur molecule will make 8 silver sulfides. And so I've accounted for the relationship between those substances as well as what quantity would need to make those 2 equivalent to 1 mole. The molecules of S8 cancel out, and the only factor that's going to affect my sig figs is my starting quantity. I have 3 sig figs in that value. So when I multiply that value by 8 and divide it by Avogadro's number, I get that there are exactly 4.00 moles of silver sulfide present. And that should get you through the final section of your review assignment.